So Josiah, the regarding the distribution functions, so basically what happened is first concept that we want to cover will be what do you mean by a probability distribution function? So for a probability distribution function, basically you need to evaluate the x, like what are the value for your x, and followed by the corresponding probability. So which is P1, P2, and P3. Can so in this context, once you evaluate the probability, whether of course you use the some of the concepts that you learned earlier to compute your probability. So once you compute your probability, the few learning points will be, of course, you can easily get the relevant probability that's required. So when it comes to the distribution function formula, concept number one is we need to take note that summation of the probability is equal to 1. So therefore, T1 at T2 at T3 will be equal to 1. Can? Concept number two. All right, Ken? So concept number two is we usually, other than the probability, we are keen to also explore the expectation. So the expectation of x, which is equals to your mu, will be equals to summation of x multiplied by its probability. So therefore, you will have x1 p1 at x2 p2 at what? x3 p3. Can? So next, so this is basically the formula to evaluate your expectation, the mean, of a probability distribution function. Concept three. Concept three, for a distribution function, concept three, we learn that how do you then get the expectation of a function gx? You'll be equals to summation of gx itself multiplied by its probability. And this formula will, so example, if I need to get expectation of x squared, you'll be equal to summation of x squared multiplied by its probability. And in this specific context, the expectation of x squared will be x1 squared multiplied by p1 plus x2 squared multiplied by p2 plus x3 squared multiplied by p3. So that's concept number 4. So right over here, we learn probability distribution function. Can we obtain the table? This is for the ease of like retrieving all the probability corresponding to the x value. And number one, summation of the probability must be 1. Number two, the expectation of x, the mu, it must be equal to x multiplied by the probability. Concept 3, expectation of a function will be summation of the function multiplied by its probability. Concept 4, finally, the more relevant results will then be your 4, which is your variance of x. So variance of x will be equal to expectation of x squared minus expectation of x whole thing squared. So summarize, this will be all the 4 important formula for probability distribution functions. So with that in mind, the next batch of concept that is relevant to probability distribution function will be, now we need to explore expectation. So what do you mean by expectation? As earlier said, it is referring to your mean. So expectation of a constant. So a few formula to take note, expectation of a constant. Now this is also relevant to all distribution function like normal distribution. Can like normal distribution, like any other distribution, this will be relevant. Can expectation of a constant will be constant itself, can equal to the constant itself. So expectation, example, expectation of 2 equal to 2. Next, expectation of a constant multiplied by x, you'll be equal to can pull out the constant a expectation of x, expectation of ax plus by, you'll be equals to expectation of ax at expectation of ay. So that will give you a expectation of x plus b expectation of y. Now, there is one that is expectation of x minus y. So that will give you expectation of x minus expectation of y. So these are all the relevant formula pertaining to your expectation. So with that in mind, moving on to variance concepts. Variance concept, we know that variance of a constant is equal to 0. Variance of a constant multiplied by x will be a times a square. Okay, a square variance of x. When you pull out the constant, you'll be a to the power of 2. All right, a squared. So with that in mind, variance of ax at by will then give you variance of ax at variance of by. And so that will give you a square variance of x plus b square variance of y. Now, so with that, you have variance of x minus y, and that is the reason why variance of x minus y will give you variance of x at variance of minus y. The minus y, when you put it out, right, it becomes minus 1 square. Okay? And with this, it also explains why, although there's a minus here, it will still be, because of the minus 1 square, it will still be positive right over here. So this will be the relevant variance concept. Okay.